Hello students, welcome to the class of Arpana ma'am. And now in this video we are going to study ideal solution. Ideal solution. Ideal solutions, practically if we are talking that it is impossible for any set of solution to behave as an ideal solution. Okay, but some examples are there in which we can take the example of N-hexane and N-heptane. Second example, bromoethane and chloroethane. These are the two examples. Other than this also many examples are there which nearly behaves as ideal solution. I said nearly. It means not 100%, but they behaves as an ideal solution. So what are the conditions for the ideal solution? The conditions for the ideal solution that for the ideal solution delta V, this is what? Change in volume equals to 0. That after the formation of the solution, there is no change in the volume of the solution. For example, as I said that A and B together, A is solvent and B is solute. It forms a solution. So if total volume of solvent is 50 ml and the volume of solute is also 50 ml, so the volume of the solution, it comes exactly 100 ml. It means that there is no change in the volume, no increase, no decrease. It means delta V equals to 0. Second, delta H. Delta H is change in enthalpy. Change in enthalpy. Enthalpy term we have studied in 11th class thermodynamics chapter, that change in the enthalpy, change in the heat energy is also equals to 0. That is no exchange of heat or any form of energy. It means this formation of the solution, this process of the formation of the solution is neither exothermic in nature nor endothermic in nature. And yes, ideal solutions, they obeys Raoult's law. Ideal solutions are those solutions which obeys Raoult's law. Delta V equals to 0, delta H equals to 0. And we have studied Raoult's law. So what is the Raoult's law? That P is the vapor pressure of the solution, is equals to PA plus PB. PA is the partial vapor pressure of the solvent. PB is the partial vapor pressure of the solute. So this is what your ideal solution. So note down this. So this ideal solution, now I am going to explain you with the help of a graph. Now we are going to see the behavior of ideal solution, as I told you the conditions of the ideal solution with the help of the graph. Okay, fine. So x-axis, here on the x-axis I am mentioning mole fraction of solute and a solvent in the solution. Okay, this side mole fraction and this side y-axis here the vapor pressure of the solution. ठीक है, these are the examples of ideal solution. So this point, at this point XA is 1. XA is 1. It means, for example, one container is here and in this container only A is present. It means that only solvent is present. At this corner XB equals to 1 means one beaker is there and in this only B is present, that is only solute is present. So as we are moving this side, XA is 1. Here I have written XA equals to 0, means the amount or the concentration or the mole fraction of the A decreases this side. And XB equals to 1 means when I am moving this side it becomes 0. So the mole fraction of the B decreases this side. So for example, XA is 1. So at this point it will be now 0.9, 0.8, 0.7, 0.6 and so on. Okay, fine. So at this point XA is maximum. There is no amount of XB. XB is 0. It means that whatever the vapor pressure I am going to measure here for this solvent, it is only and only due to the solvent. So at this point whatever the pressure is measured, this pressure is only because of solvent in its pure state. So that is represented by P naught A. P naught A, it is the vapor pressure. P naught A, it is the vapor pressure of pure solvent. Okay. Now this side XB equals to 1 means whatever the pressure this side, it is only because of solute, not because of the solvent. So that is why it is mentioned P naught B. So here P naught B is the vapor pressure of pure solute. Okay. So the position of P naught B is lower than PA. Why it is so? Because you know that it is a solute. So the amount of the solute in the solution is always less than the amount of the solvent. If the amount is less, then definitely its vapors are also less. So that is why its vapor pressure is also lower than vapor pressure of the solvent. Now let's see how to prove the Raoult's law with the help of this graph. Okay, so let us see at this point if I want to know how come this is the vapor pressure of the solution. So see this line first. This line, here the vapor pressure is 0 and vapor pressure increases slowly and slowly and slowly and reached maximum. Here you can see XB equals to 0, vapor pressure also 0. If I am moving, XB concentration increases, vapor pressure also increases. So that is why this is the line of the vapor pressure of the solute. This side same. XA equals to 0, pressure is also 0. If I am moving this side, slowly and slowly the concentration of the A increases and hence the vapor pressure of the solvent also increases and it has reached maximum P naught A. So this is the line for the vapor pressure of the solvent. This is the line for the vapor pressure of the solute. And yes, for the ideal solution, Raoult's law obeyed. It means that what? P equals to PA plus PB. It means that the sum of these two should be equal to this line. That is why this is the line of vapor pressure of the solution. So we are going to prove with the help of this graph that vapor pressure of the solution is equals to the sum of partial vapor pressure of solvent and a solute. So let's see. For example, as I told you at this point. So at this point, this is the point of the vapor pressure of the solution. So this much is the vapor pressure of the solution. So see, from here this point to this point, this is the vapor pressure of the solvent. This is the vapor pressure of the solvent. Okay, and to this vapor pressure of the solvent means it is PA. This is what? PA. Now to this I have to add PB, means this much. This is what your PB. So this PB I am going to add here. See, PB is added. Exactly you are getting the point here. It means that it obeys Raoult's law, and this is the graph for the ideal solution. Once again, this is the vapor pressure of the solution P. Then it is equals to PA plus PB. So this is what? From this point baseline to this vapor pressure of solvent. To this I have to add the vapor pressure of the solute. So I will take this much. So if it is added above this, exactly you are getting this point, the vapor pressure of the solution. So this is the graph for the ideal solution which obeys Raoult's law. Now let's see the behavior of non-ideal solution. Ideal solution already I explained. Some solutions are there which deviate from the Raoult's law. And yes, definitely such type of the solutions are called non-ideal solution. So non-ideal solutions are those solutions which does not obey Raoult's law. Non-ideal does not obey Raoult's law, that is P, vapor pressure of the solution, is not equals to PA plus PB, is not equals to. Second condition, delta V is not equals to 0. Delta H, that is change in the enthalpy, is not equals to 0. So such type of the solutions are called non-ideal solution. Now non-ideal solutions are of two types. Positive deviation and negative deviation. Positive deviation solutions, it means that the vapor pressure of the solution is greater than the sum of partial vapor pressure of solvent and solute. Here the sign of greater than. Second, delta H is greater than 0. Third one, delta V is greater than 0. Delta H is greater than 0. It means that the delta H, it will come in positive. And it comes in the positive. It means that the reaction is endothermic in nature. Reaction is endothermic in nature as the value will come in positive. Delta V is greater than 0. It means that after the formation of solution, volume increases. Volume of the solution increases. Negative deviation solutions, P is less than PA plus PB. It means vapor pressure of solution is less than the sum of partial vapor pressure of solvent and a solute. Delta V is less than 0. It means that volume decreases. Volume of solution decreases. Delta H equals to 0. It means that here the reaction is endothermic in nature. For the negative deviation, the reaction is exothermic in nature. That is, heat energy is evolved. So I think it's clear to all of you. Solutions which does not obey Raoult's law are called non-ideal solution. P is not equals to PA plus PB. Delta V is not equals to 0. Delta H not equals to 0. Ideal solutions are of two types. Positive deviation and negative deviation. Positive deviation, P is greater than PA plus PB. Delta H is greater than 0. It means positive. Positive means reaction is endothermic. Delta V is greater than 0. It means volume increases. Negative deviation, it means that vapor pressure of the solution is less than the sum of the partial vapor pressure of solvent and solute. Delta V is less than 0, volume decreases. Delta H less than 0, it means the reaction is exothermic in nature. So now in the next video, we are going to see the examples of positive and negative deviation. So this much is enough in this video. So goodbye and thank you. Good luck students. If you like this video, don't forget to like, share and subscribe to my channel. Thank you.